Hi everyone, I've been building an event planning app from scratch with three main constraints. First, I'm using Rust as the main programming language. Second, I do not use any UI framework. And third, I'm building it as a fully server-side rendering application. In the last episode, we discussed authentication, explained how it works, and did the host 0 setup and the database connection with Supabase. In this video, we will focus on building the UI by learning how server-side rendering works and how to add client-side reactivity with minimal JavaScript. Let's start by understanding the two ways of rendering a web application. Server-side rendering, or SSR, is a method where the HTML is generated on the server for each request and sent to the browser. When you visit a page, the server processes the request, builds the HTML, and sends it back to your browser, which displays it immediately. The key benefit is that the user sees the fully rendered page faster, even if some JavaScript interactions are still loading in the background. Put it simply, SSR means the server does most of the work of building the web page. Client-side rendering is the opposite. Instead of the server delivering a ready-made HTML page, the server sends minimal HTML, a shell, with a JavaScript bundle. The browser then runs this JavaScript which builds the page on the client side. The initial load may take a bit longer because the JavaScript needs to be processed before the page is fully displayed. But after that, navigating between pages can feel faster. So server-side rendering offers faster initial page load and is more SEO friendly since search engine can easily index fully rendered page. However, it can increase server load and make page transition slower. On the other hand, client-side rendering provides smoother navigation, reduced server strain, and is great for dynamic content, but it comes with a slower initial load time, potential SEO challenges, and a reliance on heavier JavaScript, which can impact performance on slower devices. So now let's talk about Rust specifically. Askama is a templating engine for Rust. It allows you to write HTML templates with embedded Rust expression. The big advantage of Askama is that it ensures type safety, meaning that the compiler checks for your template's error at compile time. This helps prevent issues with missing variable or incorrect types, making the development smoother and less error-prone. Askama expects template to be stored in a dedicated folder, usually named templates. This folder will hold your HTML file. Think of template as reusable component that can be combined and extend to create more complex UIs. For example, you might start with a base HTML file that contains common sections like the head and the body of your HTML page. Askama allows you to define content block within the base template, which other template can fill in by extending the base template. So you could have a sidebar template that extends the base layout, providing content for the main block, while also adding a new block for further customization. You can also use double curly bracket to dynamically insert variable into your HTML. These variables are defined when creating the template in Rust, allowing you to render dynamic content with ease. Askama provides macros that allow us to create struct tied to a specific template, automatically populating the template with variable when rendering. For styling, Tailwind CSS is a utility for a CSS framework that makes styling web application efficient and modular. Rather than writing custom CSS, you apply predefined classes directly to your HTML to control the layout, typography, spacing, and more. This approach gives you flexibility while keeping your CSS manageable. DaisyUI builds on top of Tailwind and provides a set of pre-built UI components that you can use to speed up development. Things like button, form, model, and card are all available outside the box. You can install DaisyUI and Tailwind via CDNs, but this has performance drawback and limits your ability to create custom styles. To avoid this issue, setting up Tailwind locally using Node.js is better. Start by initializing a Node project and install Tailwind through npm. Then in the config file, you can customize the default settings and create your own style and add DaisyUI as a plugin. Once your configuration is set, you can build your CSS using npm. After building, make sure to include the output CSS file in your HTML. Rust allows you to specify a folder for static content such as CSS file, and anything in this folder will be served to the browser when the app loads. However, Rust doesn't automatically compile the app when file change in the static folder. To avoid having to manually recompile the project every time you update your CSS, you can create a build.rs file which ensures that Rust recompile whenever the static files are modified. We need a way to provide client-side reactivity that still feels like a client render application, and that's where HTMX comes into the picture. HTMX is a lightweight JavaScript library that allows you to add client-side interactivity to your web page without writing custom JavaScript. It works by letting you send HTTP requests directly from HTML element and update part of the page with the response, making your app feel dynamic without needing complex front-end framework. Think of HTMX as a way to enable just enough interactivity in your web application without going full single-page application. For this project, I used HTMX to create a simple profile page. Whenever a user edits their profile details, HTMX intercepts the form submission, send the data to the server via HTTP, and update the relevant section of the page with the new information. The page feels responsive because the updates happen inline. HTMX loads the new content without needing for a full page reload. Next week, I will focus on refining the app visual layout using the tools we covered today. I will also begin building the event creation flow, one of the app's core features. So stay tuned for that. Thank you all for watching. See you in the next one.